Good morning to all of you. Today our subject is mechanics of solid mass. Last class I had done the theory in temperature section and also thermal stress. Today I will do some problems relating to this theory. Right. This is problem number 15. The question is a rod tapers uniformly from 40 diameter to 20 diameter in a length of 400 is subjected to an axial load of 5000 Newton. 5000 Newton. Find the stress in the rod. Take E is equal to X modulo E is equal to 2.1 into 10 to 5 Newton per mm square. Right? Rod uniform tapers. This is figure. Tapering section. Tapering section tapers from this is D1, this is D2, this is P, this is P, length L, right? Diameter D1, D2, length L, load P. So first write the given data. A rod tapers uniformly from 40 to 20 diameter. But D1 is equal to 40 D2 is equal to 20 right? In a length of 400 L, 400 If the rod is subjected to an axial load of 5000 Newton, P is equal to 5000 Newton and S modulus E is equal to 2.1 into 10 to 5 Newton per mm square. Find the extension of the rod, delta L. What delta L is equal to? Extension of the rod. Clear? Now delta L is equal to 4 PL by I D1 D2, right? Four into P 5000 Newton L 400 by pi into E 2.1 10 to 5 Newton per mm square. D1 D2. What is D1? 40 D2 20 right? This is Newton cancels, m square cancels. The answer is Clear? The answer is 0.0515 The answer is 0.0151 Delta L is equal. Clear? Next question number 16. This is given data. This is we'll find out delta L. Given data is L1, D1, D2, L, P, E. They are given data. Our find data is delta L, extension of the rod. What delta L is equal to? 4 PL by I D1 D2. 4 into P means 5 Newton, L 4 mm by pi into E 2.05 Newton per mm square into D1 D2 40 mm 20 mm. So mm square cancels out. Clear? Newton cancels out. So only this is mm. The answer is in mm. Right? This way 0.0151 mm. You use a calculator to find the answer. Next question number 16. This is question number 16. The question is find the modulus elasticity. This is young modulus for a rod which tapers uniformly from 30 mm to 15 mm in a length of 350 mm when subjected to an axial load of 5.5 kilonewton and the extension is 0.025 mm. Now, first I'll write the given data, then solve the problem. Find Young's modulus. When the rod tapers from 30 mm to 15 mm, D1 is equal to 30 mm, D2 is equal to 50 mm. For length of 350 mm, L, what is L is equal to 350 mm. This is 15 mm. Subject to load of P, 5.5 kilonewton. P is equal to 5.5 kilonewton and the extension is 0.025 mm. Extension delta L is equal to 0.025 mm. This is 5.5 times 3 Newton. Right? Now, we know delta L is equal to 4PL by D1 D2. This is for circular tapering section, for circular tapering bar. Last class I have done the theory. So what is it? E is equal to 4PL by pi into delta L into D1 into D2. Clear? E is equal to 4P 5.5 10 to 5 3 L 350 mm by pi into delta L 0.025 D and D2 30 mm into 15 mm. Right? Solve the answer, use calculator and the answer will be E is equal to 2.178 10 to 5 Newton per mm square. Clear? This E is equal to 2.178 10 to 5 Newton per mm square. Next class. Next problem. Now 17. This is question number 17. Very important question. This is a composite bar. This consists of one steel and another is aluminum. Clear? The steel bar having diameter 50 mm, aluminum bar having diameter 25 mm. The steel bar length is 600 mm, aluminum bar length 300 mm. Young's modulus for steel is equal to 10 Newton per kilonewton per mm square. Young's modulus for aluminum is equal to 74 kilonewton per mm square. Right? Alpha S, coefficient of linear expansion. Coefficient of linear expansion for steel 11.7 into 10 to the minus 6 per degree centigrade. And alpha L is equal to for aluminum 23.4 10 to the minus 6 per degree centigrade. Clear? First, write the given data. Find what will be the stresses in the two bars when the temperature is 21 degrees centigrade. Initial temperature is 30 degrees centigrade, final temperature is 20 degrees centigrade. Clear? When the two supports are yielding. Next, when the two supports come nearer to each other, right, by 0.1 mm. Both cases, we find stress for steel, stress for aluminum. Now, first write the given data. First write the given data. Now, for steel, diameter D is equal to 50 mm. Length LS is equal to 600 mm. And Young's modulus ES is equal to 210 kilonewton per mm square. Kilonewton per mm square. Clear? This is 210 into 10 to 3 Newton per mm square. Alpha S, coefficient of linear expansion for steel. Alpha S is equal to 11.7 into 10 minus 6 per degree centigrade. The temperature falls from 30 degrees centigrade to 21 degrees centigrade. Clear? So delta T is equal to del T is equal to 38 minus 21, 1 degree centigrade. Now, similarly, for aluminum, diameter, length 20 mm, 300 mm. Diameter DS is equal to 25 mm. Length LS is equal to 300 mm. Clear? X modulus L and not S. L. Diameter D aluminum is equal to this. L aluminum is equal to this. E aluminum. 74 kilonewton per mm square. 74 into 10 to 3 Newton per mm square. Clear? Similarly, alpha aluminum is equal to 23.4 10 to minus 6 for degree centigrade. This is given data. Now find the stress. Let sigma S is equal to stress in steel. Sigma aluminum is equal to stress in aluminum. Clear? Now find out area. What is area? What is area? Steel is equal to pi 4 into 50 square mm square. Area for aluminum is equal to pi 4 into 25 square mm square. Clear? Now, since both cases, both ends are fixed, and when subject to load, the load is the same. So, sigma A, sigma S, AS is equal to sigma L into A aluminum. Right? Since in both cases the load is same, both under fixed, so sigma S AS is equal to sigma L A aluminum. This implies sigma S into pi 4 into 50 square is equal to sigma aluminum pi 4 into 25 square. Right? This pi 4 cancels out. This 25 50 50, this is 4. So sigma aluminum is equal to 4 sigma S. Right? This is equation 1. Equation 1. Without calculator, the problems cannot be done. So you use calculators and find the answer. Clear? Now, the temperature decreases from 30 degrees centigrade to 21 degrees centigrade. Hence, there is a contraction. Clear? So, contraction of steel bar. Contraction of steel bar. Delta LS. What delta LS? LS, alpha S, delta TS. Right? L alpha T, L alpha delta T. So this is delta LS. Put all the values. What is LS? 600 mm. What is alpha S is equal to 11.7 into 10 to minus 6. Delta TS. Delta T, not S, delta T. This is 70 degree centigrade. This is for degree centigrade. This is mm. So degree centigrade cancels. The answer is in mm. Right? Delta S. The delta S becomes 0.1193 mm. 0.1193 mm. right? This is contraction for steel bar. Similarly, contraction for aluminum bar. Aluminum bar. Delta L L L L delta alpha L delta. Clear? This is put all the values. What is L L? Delta L aluminum is equal to what is L L? 300 mm. Alpha aluminum. What is alpha aluminum? 23.4 10 to minus 6 for degree centigrade. Delta T 70 degree centigrade. So degree centigrade cancels out. The answer is in mm. So delta L aluminum is equal to 0.1193 mm. Right. Now, now total contraction. Total contraction delta L is equal to delta L steel, delta L aluminum. So delta L is equal to delta L steel 0.1193 mm plus 0.1193 mm. Right? What is this? This is equal to delta L total delta L is equal to 6, 18, 3 to 0.2386 mm. Clear? What is delta L? But delta L is equal to delta less delta L aluminum. What delta less? Stress by sigma s by what E is equal to what E is equal to stress by E. Clear? E means delta L is equal to stress by E. What delta L is equal to sigma L by E. Right? Put here. So delta L is equal to delta less sigma s Ls by Es plus sigma A L by E aluminum. This is formula to find sigma S and sigma L. Now put the values. Clear? This value delta L, contraction or extension. This S for steel, L for aluminum. S for steel, L for aluminum. Right? Now delta L 0.2386 is equal to what is sigma S? Sigma S is equal to 4 sigma A. Sigma A is equal to 4 sigma S. Sigma A is equal to 4 sigma S. Now put all the values in this equation. Tal 0.2386 is equal to sigmas. What sigmas is equal to? Sigma 4 sigmas. नहीं sigmas what is LS 400 by yes full for steel 210 into 10 to 3 plus sigma L. What is sigma L? 4 sigmas L aluminum 300 by E aluminum, Young's modulus for aluminum. This is 74 into 10 to 3. Right? Now, from this equation, you can find out sigmas. Sigmas. Now, sigmas becomes 12.51 Newton per mm square. Clear? May common sigmas, right? And after solution, this becomes 12.51 Newton per mm square. Next, sigma L. Sigma L. What is sigma L is equal to? 4 sigmas. 4 into what is sigmas? 12.51. Clear? This becomes 12.54. 50 something. Hello? 52.01 Newton per mm square. This is when supports not yielding. Clear? Now, when supports come to near each other by 0.1 mm, bit 2. This is question when the supports not yielding, unyielding. Now, next, bit 2, when the supports come near to each other, near to each other by 0.1 mm. Clear? In this case, that is delta. That is delta is equal to 0.1 mm. Clear? In this case, total contraction delta is equal to, in this case, delta is equal to 0.2386 minus delta. Clear? This is delta is equal to 0.1386 mm. Means minus 0.1. This is 0.2386 minus 0.1 mm. Right? This is delta. Now, the delta is equal to sigmas LS by ES plus sigma aluminum L aluminum by L aluminum by E aluminum. Right. Now put all the values. Now for delta L, 0.1386 is equal to sigma s. Find out sigma s. LS 600 by ES. What is ES? ES is equal to 10 into 10 to 3 Newton per mm square plus L sigma aluminum 4 sigma steel L aluminum. What is L aluminum? L aluminum is equal to 300 mm by E aluminum 74 3. From this equation we find out sigma s. What is sigma s is equal to? Sigma s is equal to, could find out 7.27 Newton per mm square. Clear? Similarly, this is equal to sigma aluminum is equal to 4 sigma s 7.27 into 10 to 4 29.25 Newton per mm square. Clear? This is for steel, this is for aluminum. Steel sigma s, aluminum sigma L. Now both cases we do solve the problem. First case when supports are on yielding. Second case when supports yield by an amount 0.1 mm. Clear? Next I will do question number 18. Right? This is question number 18. Clear? The question is a rod is 2 meter long at a temperature of 10 degrees centigrade T1, length 2 meter. Find the extension of the rod when temperature rises to 80 degrees centigrade T2. Initial temperature 10 degrees centigrade, final temperature 80 degrees centigrade. If this expansion is prevented, means some stress is induced. Find the stress induced in the material of the rod. Take E is equal to 1.1 10 to 5 Newton per mm square. Alpha is equal to 0.00012 per degree centigrade. 0.00012 per degree centigrade. Clear? Now first find out the expansion of the rod, delta L. First write the given data. Now a rod is 2 meter long. What is L is equal to? 2 meter, 2000 mm. Clear? At 10 degree centigrade, T1 is equal to 10 degree centigrade. T2 is equal to 8 degree centigrade. So delta T is equal to T2 minus T1. Clear? 80 minus 10, 7 degree centigrade. Now Now we find out expansion. The delta L is equal to expansion of the rod because when temperature rises, the rod expands. Clear? In this case, Young's modulus is equal to 1 under 5 Newton per mm square and alpha is equal to 0.000012 per degree centigrade. Clear? What is expansion alpha? Now, we already derived the equation alpha is equal to the delta L. L2 minus L1 by L1 into T2 is T1. This equation we derived from physics. Clear? Now, in this case, alpha is equal to delta L by L in delta T. So, what delta L is equal to? L alpha delta T. Clear? Put here. So, delta L is equal to L alpha delta T. What is L? 2000 mm. Right? What is alpha? This is alpha. 0.000012 for degree centigrade into del T. What del T? 70 centigrade into 70 centigrade. 70 centigrade cancel out. Find out delta L. Clear? Use calculator. Solve the problem. The delta L becomes 0.0168. 0.168 mm. You solve the answer. Clear? Next, stress. Now, when the stress is prevented, what stress applied in the rod? Stress is equal to, what is stress is equal to? Now, delta L is equal to L alpha delta T. Clear? First 10 is equal to delta L by L alpha delta T by L. What is 10 is equal to alpha delta T. This is strain. Stress. What is stress? Stress sigma is equal to E into E. Strain into Young's modulus. Right? What is strain? Alpha delta T. Alpha into delta T into E Young's modulus. This is E. Right? This is your stress. Now, stress is equal to what is alpha? 0.000012 for degree centigrade. Del E, del T. What is del T? 17 degree centigrade. 70. Delta, what is delta T? Delta T is equal to 70 centigrade. E, what is equal to? This is E. 1 into 25. Clear? Now stress. For degree centigrade cancels out. The answer is Newton per mm square. The answer is cancel out 84 stress. Right? So use the formula in this problem. Use the formula delta L is equal to L alpha delta T. Use the formula delta L is equal to L alpha delta T. Stress is equal to E is equal to delta L by L. Clear? Means alpha into delta T. Stress is equal to sigma is equal to E into E alpha delta into E. Clear? These formulas are used in this problem. Right? Next question I will do and use this formula. Now we will do question number 19. Now this is question number 19. Right? I done all. I will write all the formula here. You will apply these formulas to this problem. The delta L, strain, stress. Right? Now the question is a steel rod of 3 cm diameter and 5 meter long. First write the given data. Diameter D is equal to 3 cm, 30 mm. So what is area? Area is equal to pi f4 into d square. So pi f4 into 30 mm square. Clear? So A is equal to pi f4 into 30 into 30, 15 15. Clear? So 225 pi mm square. Area is equal to. Right? Now area diameter, length 5 meter long, L. What is L is equal to 5 meter, so 5000 mm. Clear? Two grips and rod is maintained temperature of 95 degrees centigrade. Determine the stress and pull required when temperature falls to 30 degrees centigrade. Clear? 95. T1 is 95 degrees centigrade. The T1 is equal to 95 degrees centigrade. T2 is equal to 30 degrees centigrade. So delta T is equal to T1 minus T2. So 95 minus 30 is equal to 65 degrees centigrade. Delta T is equal to. Right? Now if the both ends are not yield, next the both ends are yield by 0.12 cm. And take E is equal to Young's modulus E is equal to 2 into 10 to 5 meganewton per mm square. This is equal to 2 into 10 to 5 into 36 Newton per mm square. Clear? So this is 2 into 10 to the 11 E is equal to next alpha. What is alpha is equal to 12 into 10 to the minus 6 4 degrees centigrade. Clear? And when yielding, del is equal to 0.12 cm, 1.2 mm. Case 1, now two cases will arise. Case 1, not yielding. Case 2, when yield by an amount of, what is the amount? 0.1 mm. Right? So case 1, bit 1, when on yielding, the delta L alpha delta T, strain, stress. What stress is equal to? Stress sigma is equal to alpha delta T into E. What is alpha? Stress is equal to, what is alpha? 12 10 to the minus 6 for degree centigrade. Del T is equal to 65 degree centigrade. E is equal to G 2 into 10 to the 5 into 26 Newton per mm square. 26 cancels out, minus plus for degree centigrade cancels out. Right? Now stress. Find the stress in Newton per mm square. Right? The stress may be 156. This is 156 Newton per mm square. Now load is P is equal to stress into area. Stress into area. What is stress? 156 Newton per mm square. Area 225 pi mm square. Mm square cancels out. This is Newton. Clear? P is equal to 156 into 225 pi Newton. Right? The answer is 110,269 Newton. Use calculator. Clear? I am not using calculator. So I am seeing the answer. Clear? You do the problem using calculator. This is answer for load, answer for stress. Case 2, when yield by an amount 0.12 cm, that is 1.2 mm. This is case 2. Case 2, when yield means the supports come nearer to each other. Clear? When the supports yield by 0.12 cm, that is delta is equal to 0.12 cm. What is 0.12 cm? 1.2 mm, right? The delta. Now we'll find out change in length. Now in this case, delta L is equal to L alpha delta t minus delta. This is change in length. Clear? So stress is equal to change in length of L. Right? Now delta. So stress is delta L. E is equal to delta L by L. What delta L? This is L alpha delta t and del L. Clear? This is equal to L alpha delta t by L minus delta L by L minus, you find, okay, this answer clear. This is delta L. E. What is stress? UD. Now stress sigma is equal to E into E. What is G? This is L alpha delta t minus del by L into E. Stress. Clear? You put all the values and get the answer. Stress is equal to 108 Newton per mm square. Or put values. So stress is equal to L. What is L? 5000. 5000. What is alpha? 12 into 10 minus 6. Del T 65 minus delta 1.2 whole by 5000. Answer is Newton per mm square into E. What G? E is equal to this 2 10 to 5 11 into 2 into 10 to 11. Answer Newton per mm square. Here. Now the answer is stress is equal to 108 Newton per mm square. Stress, load. Clear? The stress after solving this, you get the answer 108 Newton per mm square. Stress is equal to this. Load is equal to stress into area. What is area? 225 pi mm square. So the stress is equal to 108 Newton per mm square into 225 pi mm square. Clear? So P is equal to Newton ms or ml cancels 108 into 225 pi Newton. Clear? This answer P. This may be 76408 76340.7 Newton. Calculator. Use calculator. Multiply this. You get the answer 76340.7. Answer is Newton. Right? This is our problem number 19. Next class, I will do some theory as well problems. The theory is strain, what is strain, types of strain, linear strain, lateral strain. Clear? Then bulk modulus, shear modulus. These are topics, theory. Then I will do some problems. Thank you. Make likes, say subscribe to all my videos. Thank you.